Hi students, so let's look at this question here, which was taken from the year 2020 NYJC's Common Test 2, Paper 2, Question 3. This question is on application of differentiation. So the diagram below shows a city map of two towns. A and B are separated by a river. So this river here is in this middle here, right? And a bridge is to build between the two towns, which are opposite side of the river, with a uniform width of r km. Okay, so meaning it has to be perpendicular to the river, right? So this is RKM, this is RKM. Oh, they did say it's perpendicular. And two towns are PKM apart this side. And A is 1 km from the riverbank, and town P is P km away. A bridge has to be built perpendicular to the riverbank, so this is 90 degrees here. Let's take note. Okay, measure along the way. Find the distance x in terms of B and P such that the distance traveled between town A and B can be minimized if B is bigger than 1. Now, the thing now is essentially you need to know that what are the variable and what are the constants, right? So you have to know that 1 km is obviously a constant. This is a constant as well. Okay, and B has to be a constant because the distance cannot change. P obviously is also a constant. These are all constants, right? Okay, constant. Now the one that is changing is actually this xkm here. Xkm is actually the one that you need to change, because with a different xkm you can vary this length, and this length will change. Okay, so let's see how we can try and understand this part here. So the distance traveled is quite okay. I think this distance here, you can know that this is b square plus x square, right, just by Pythagoras theorem, right? So so distance from B to bridge entrance would just be square root b square plus x square. Okay, then distance from bridge exit to A, okay, will just be here to here. So you need to find the distance here. So this distance will just be P minus X, right? So this is P minus X. And what we get is actually just P minus X square plus 1 square. Okay, this is the distance that we are looking at. Then the next thing is, of course, we try and see what can we make sense of the thing that we just found. All right, so we so now we need to find the distance traveled, right? Distance traveled from town A to B. Oh, this is town A to B. So distance traveled from A to B. You just let it be a D distance. We're just gonna use P minus X square plus 1 plus B square plus X square plus R, right? R is this length here in between. Okay, once we're done already, we are going to differentiate it, right? So we're going to differentiate this expression here. How do we differentiate it? So we're going to do dx. Okay, so d is actually just bracket. Can we just put this as a P minus X squared plus 1 half. So we don't need to, question did not ask us to show that is minimum. So that is one thing that we are happy about. So what we can do is we want to minimize this. So dx would be just equals to half, and that will be P minus X squared, chain rule, minus half. So this will just be minus 1 minus half. And the inner will be P minus 1x1 multiplied by 1 minus x. Okay, x is a variable. X is a variable. I repeat, x is a variable. And after which so maybe I just do chain rule of outer layer, inner layer. Okay, so when you differentiate it, just make sure you know that this is the outer layer, this is the inner layer. Okay, so then subsequently this will be half b squared plus x squared, and this is minus half, and the inner layer will be 2x. R will be 0 because this is a constant. Okay, so you must be very mindful of what are the constant and what are the variables. So once this is done, we could just let dx be 0 for at stationary value. Dx is 0. So this case here will be half. Maybe I just do this carefully. So this is 1 over square root p minus x squared plus 1, and this will be minus 2 p minus x. Okay, and that will be plus x over square root b squared plus x squared. My goodness, this seems like you need to do a lot of manipulation here. So we are going to just let this be 0. Okay, and that will give us p minus x. Simplifying it, this will bring over. This will be p minus x squared plus 1 over b squared plus x squared. Okay, goodness, that is pretty okay. It's life-saving here. Then the next thing is, of course, square both sides, because this one looks so annoying, right? So we're just going to square both sides here, and we're just going to quite manipulate. It's just, I think the difficult part is just the manipulation, but once you see past the manipulation, it's pretty okay. Okay, this is x squared plus 1. This is x squared over b squared plus x squared. And we're going to continue this on the next page. So what I did was I just cross multiply, and I'll get this expression. Just cross multiply here. Double check. Okay, then I'm not going to explain my p minus x squared, because it looks like is very is going to be quite hassle to I'm going to expand this first. Just keep it intact. Don't try and expand. Just try and be intelligent with your manipulation, because you're already dealing at a higher level of math. So you see that I get this expression here. These two can be cancelled out. So then you have it's better that way, right? So this case here, what we get is actually b squared p minus x squared equals x squared. Great job. So b is, so now we need to find the distance x, right, in terms of b and p. So we have got our x would just be square root, so it's plus minus b squared p minus x squared. So must be mindful of this, because we're not sure whether which should we reject. Okay, well, so just gonna slowly do this. Or x equals to minus b p minus x. So I wouldn't know until I expand it. bp minus bx equals to x. So x is 1 plus b. This is bp. And the next one would be x equals to minus bp plus bx. And this will be 1 minus b x equals to minus bp. So we need x to be a positive number. So just be mindful of that. 1 plus b. Or minus bp over 1 minus b. Okay, that's the thing there. So we know, how will we know that this so let's see how we can actually reject one of it, because it can't be like taking both, right? The one that is given us the clue is this b bigger than 1. This is important. So b bigger than 1 is a clue there, but I think so this case here will just be bp b minus 1. So b is bigger than 1, meaning b minus 1 will be 0. So this will also be a positive value. This is a positive value, and this is also a positive value. But be mindful of that, because let's look at this. This is b over 1 plus bp. Then this is b over b minus 1p. We see which is bigger. This would mean that you need to reject this, as x is less than p, right? You look at this value here, b 1 over b minus 1. This will definitely give you more. It's a b over b minus 1. Okay, would definitely give you more than, because the one below is smaller. Okay, the one below is smaller. So this will give you more than 1. So you don't want the multiplier to be bigger than p. So x has to be b over b times p over 1 plus b. Just remember that. You need to evaluate. I think the hard part is the evaluating part at the end here. So you don't need to verify that the distance is minimum, but you need to be able to tell that this is to reject this is because you do not want this x to be a bigger multiplier than p. Okay, you can see here your x should be smaller than p. Yeah, that's about it. So if you have any questions or comments, please let me know, and I'll see you in the next question.